In this video, I want to define elastic and inelastic collisions. Elastic collisions, these are collisions in which the kinetic energy remains the kinetic energy is constant. It remains constant. We can say remains constant. Okay? And then inelastic collisions, these are collisions in which the kinetic energy does not remain constant. All right? If you have an elastic collision, that's nice because you can use the fact that the kinetic energy doesn't change to help you solve the problem. Not so with an inelastic collision. All right? So what I'd like to do is work out a few examples to get some practice using these definitions. First of all, let's talk about a bomb exploding. Let's say the bomb was initially at rest on a desk and it explodes. Is the total momentum constant before and after the explosion? The answer is yes, because there's no net force. Is the kinetic energy the same before and after the explosion? Think about that one. So the answer is that the kinetic energy is not the same. Before the explosion we had 0 joules of kinetic energy. Afterwards we have all kinds of pieces of the bomb and moving in all different directions. And they all have kinetic energy, and it's additive. All those kinetic energy contributions will be positive, and they'll add up to a bigger positive quantity. All right, so the kinetic energy is not conserved in that situation. What about the situation where you have 2 ice blocks moving on a frozen lake with negligible friction, and maybe they stick together, maybe because the moving block has a sticky side, and you may have worked out a problem like this before. All right, so let's say they're both 4 kilograms, and let's say that the moving one has a velocity of 10 meters per second, and so they're going to stick together because the moving one has a sticky side for some reason. Okay, so the question is this elastic or inelastic? All right, there's no net force, so we know that the total momentum is conserved. So P total initial equals P total final. So 4 times 10 equals, and then after they're moving, let's say they're moving with a velocity v after the collision, so 4v plus 4v, that gives you the total momentum afterwards. So v is 40 divided by 8, which is 5 meters per second. Okay, that's all great, but that doesn't tell us if it's elastic or inelastic. Let's now calculate the initial and final kinetic energy. So Ke initial was 1/2 times 4 times 10 squared, which is 200 joules. Ke final, they're both moving with a velocity, both blocks are moving with a velocity of 5 meters per second, and they're stuck together. So we have 1/2 5 times, 1/2, the mass is 4, not 5. 1/2 4 times 5 squared, and then we have the kinetic energy of the second object will also be 1/2 4 times 5 squared. So that adds up to, let's see, 2 times 25 plus 2 times 25 gives 100 joules. Okay, so the kinetic energy was not conserved. All right, this is not only is it inelastic, it's very inelastic. In fact, when things stick together, That's sometimes referred to as totally inelastic. In this case, we lost half of our kinetic energy. Okay? Now, let's see if another example is elastic or inelastic as well. So this time, let's do the example where two blocks, one of them's initially moving, it hits one, and then the stationary one starts moving, and the one that was initially moving comes to rest. And to keep it simple, we'll say that they both have 4 kilograms of mass, like in the previous example. And let's say the first one is again moving 10 meters per second. And this time again, the moving one's going to come to rest, and the stationary one's going to move after the collision. So P total initial equals P total final. And so 4 times 10 equals 4 times V. Clearly, the one that starts moving is going to have the same velocity as the one that was initially moving. It has the initial velocity of the one that was initially moving. Okay, so now let's also calculate the initial kinetic energy. 1/2 4 times 10 squared is 200 joules again. And KE final, this time we only have one block moving, so we only have one contribution, one term here. 1/2 times 4 times 10 squared also gives 200 joules. So initial kinetic energy is equal to the final kinetic energy. It is an elastic collision.